Hello, this is Anahita Khadodadi. I'm an assistant professor at the School of Architecture and Urban Planning at the State University of New York at Buffalo. My field of work relates to computational design in the field of architecture and combating climate change by mitigating the amount of carbon emission to our environment. So my field of work is mostly kind of going back and forth between sitting at the computer, running analysis, and at the same time working at the studio with students and building up prototypes of structural systems that we hope to develop. And by those prototypes, we hope to combat the climate change and global warming. Carbon is a chemical element that makes up about 0.02% of Earth's crust, and we use it in different matters and forms. In the field of architecture and building industry, what we mean by carbon refers to atmospheric carbon compounds, primarily carbon dioxide. And in our field, we work hard to prevent excessive production and emission of atmospheric carbon because it is one of the prominent contributors to global warming. In the field of architecture and building construction, we investigate different ways that we can prevent excessive emission of carbon dioxide and innovative ways that we can capture atmospheric carbon and store it as solid matters. One stream of research in our field is all about reducing carbon emission during the operational time of buildings when we heat, cool, and condition our indoor environment by consuming non-renewable energies. Many scholars, many of my colleagues develop analytical methods for computing buildings' energy demand. This focus is on reduction of operational carbon emission. Another stream of research, which is mostly related to what I do, addresses the carbon emission during the pre- and post-operational time of the building. The time frame that raw materials are extracted, transported to the manufacturing site, and building materials are produced and transported to the building site. Also, the embodied carbon is related to the end of the lifetime of a building, when building gets demolished and its elements and assemblies go for reusing, recycling, or dumping in the waste. My research primarily aims to mitigate the impact of climate change by reducing the building's embodied carbon through assisting architects in choosing materials with low carbon footprint and introducing them design methodologies and approaches that allow reuse of building components. I run a studio which is called Design for Disassembly. We develop structural systems that can mostly be reused and go through a second or more life cycle. Our goal is to reduce carbon emission by skipping extraction of raw materials and manufacturing new building materials. Also reducing the disposal of construction and demolition materials offsets the social environmental impacts associated with the extraction and consumption of materials, supports the circular economy and creates employment. It reduces fewer disposal facilities and conserves landfill spaces. I believe climate change is not just an environmental crisis, but it is rather a socio-economical and environmental crisis that we should combat and try to resolve it, because it not only affects our landfills and natural environment, but also it interferes the chain work, employment systems, and also creates many social discriminations, particularly for communities that are kind of marginalized and needs assistance.